Good day, everyone. Theme of presentation is Chatbot application to support indoor temperature control. Nataliia Kulykovska, Артур Timenko, Svetlana Hrushko, Vadim Shkarupylo. The Internet of Things is one of the most promising areas of information technology development, which involves communication between various devices and sensors via the Internet. IT systems can collect, process, and analyze large amounts of data generated by these devices and use them improve people's quality of life, business efficiency, and environmental safety. However, in order for customers to be able to easily and conveniently interact with IT systems, intelligent and natural user interfaces are needed. Chatbots are one such interface that uses uh, artificial intelligence and neural language processing to simulate conversation with people or other chatbots using text or voices messages. Chatbots can provide users with comfortable and efficient assistance by answering their questions, providing them with more interesting answers, directly responding to their problems. Furthermore, the article highlights the ability of chatbots to process the substantial amounts of data generated by sensors and IT systems and they present this information in a format that's readily compressible and actionable for users. This study examines an IoT system comprising sensors, a code-based platform for data storage and processing, a database, and a chatbot interface to facilitate user interaction. Uh, Arduino boards are chosen for IoT devices. The Python development language is used due to its extensive libraries, support for data analysis, and easy of integration with IoT devices. PostgreSQL relational database management system is used to store temperature data. This technology provides robust support for SQL queries and can handle large data sets. The PsyCopy2 library is used to connect to the database from the cloud platform. The chatbot is written in Python. For the OMP module, the SPACE library is used, which offers advanced functionals for tokenization, recognition of named objects, and analysis of syntactician dependencies. Python also provides pre-built models for different languages, which allow for faster application development. SPA-C can be used to analyze user queries, extract important objects, and understand the context to formulate meaningful answers. We can consider the algorithm of chatbot operation with IoT. Receiving a text command from a user, processing a text command using neural language analysis, next determine the action to be performed based of the processing of a text command, uh, interaction with the storage system to obtain information about the temperature in the house, application of the temperature control algorithm to change the setting of the thermoregulation system in the house, update the temperature data in the storage system, and sending a response to the user with the results of the action performed. The chatbot was evaluated in a real-world scenario, tested within a hangar facility spanning 800 square meters. The environment was equipped with a variety of the IoT-connected devices, including temperature sensors, air conditional units, window and door sensors to detect opening, closing, as well as a ventilation system, figure 1. During the test, the chatbot demonstrated its ability to autonomously maintain the temperature within the hangar utilizing the air conditional system to ensure the temperature did not extend to 32 degrees Celsius. The chatbot interface allowed users to interact with the system through text commands, enabling them to adjust the target temperature as desired. Figure 2. Critically, the system incorporates control mechanism to monitor the status of window and doors as well as the ventilation system. Temperature readings were recorded at half-hourly intervals, providing the chatbot with the necessary data to intelligently regulate the environment. The autonomous nature of the chatbot's operation allowed it to proactively manage the temperature without content human supervision. However, the system was also designed to provide users with a seamless interface or to directly manipulate temperature settings, overriding the autonomous control if necessary. The balance of autonomous operation and user interaction represents a key third of the chatbot-driven IoT solution. Thought this real-world evaluation, the chatbot's capabilities were thoroughly tested, demonstrating its ability to effectively maintain optimal environmental conditions within the large hangar space while also offering intuitive user control capabilities to accommodate a specific user preference and needs. The system provides for critical situation, for example, an IoT temperature sensor failure or erroneous user command that can lead to a dangerous change in indoor temperature. Therefore, protection mechanisms have been implemented, such as automatic temperature change and notification of occurrences of the problem. This paper investigate the functionality of chatbots for indoor temperature control using Internet of Things systems. The paper analyzed modern programming languages used in IoT systems and considered the architecture and algorithm of the proposed system. The system integrates a chatbot driven by natural language processing with temperature sensors, air conditioners, and database. Users can easily use commands through the chatbot to regulate the temperature, monitor the current status, and receive notification of critical situation. The main components of the system and modules for a chatbot controller, IoT hub, and IoT sensors. The core of chatbot is the SPA-C library of the language processing. The system uses a Python programming language, PostgreSQL for the database, and AWS IoT core platform. The system has been successfully tested in the real-world environment of a large hangar. The chatbot has demonstrated the ability to autonomously maintain the desired temperature, interact with the condition system, and respond to use commands. The system also has mechanism to protect against critical situations such as sensor failures or dangerous commands from users. The research demonstrates the potential of chatbots as an intelligent user interface for IoT systems, combining automated control and convenient human interaction. The development system is flexible and scalable, which opens the prospects future for its future environment and implementation in various fields. Thank you for your attention. That's all.